Good morning. How are you? Hello, hello, hello. This will be a quick one today. I'm not anticipating we're going to get many people since we're only covering the quiz today. That's it. Hey, real quick. Hi. Real quick. Are you all using a private email to log into YouTube? Okay. Respond yes if you're using a private email to log in. Hello, everybody. Okay. All right, that's kind of what I figured we had to do in order to get things to work. So that's perfect. Okay, because there's a couple of other teachers that are looking at doing this, but they're not allowing us to do it through our school email. So the district is limiting us even more and more and more. I'm not going to do that. So if you're all okay doing a private email, we'll be just fine. So, okay, so welcome everybody. This is going to be a fairly short one because really all we're going to do is we're going to take a look at the lesson quiz from yesterday. So basically we've got 4 questions that we're going to take a look at. And then from there, you're going to be on to looking at section 7.2 tonight. So the lesson is all posted there. The notes are all posted there. So then you'll work on that tonight. We'll go through questions in the live feed tomorrow. Nope, we're doing that all tomorrow. We're going to take care of that. So today is just about the, ooh, that was ugly. There, that's better. Yeah, so today is all about just doing the quiz. And then tomorrow you'll have your lesson quiz on section 7.2. So if you want me to cover a couple of questions in the worksheet, I can. But that was not part of the intent of today. That's perfectly fine. So, all right. So from here, starting in. So in this particular problem, okay, so I've got it right here. There's the answers. Okay, so you can see where my answers are here. So as we do this, where we saw a couple of issues is problem number 1. You know, this was all matching, so you had to make sure you had the right information and dealing with the right context. So the biggest thing to notice in problem 1 is that after reading your information, okay, so they're giving us in the year 2000 that the population is 9157. Okay? And then in 2010, the population is now 8712. Okay? So what that needs to tell us here, as I start doing problem number 1, ooh, come on. I don't know what's happening here. There we go. Okay. So you'll notice also in that they're saying that the change was 0.04%, or excuse me, 0.4%. Each year. Now, this was done specifically here, so you would have to determine whether or not we're going to be looking at a decay situation or looking at a growth situation. Well, how do I figure that out? In problem number 1, we're asked to write the model. So what I need to look at here is that since they're saying t is equal to 0 is the year 2000, I got to take a look at what's happening. So from year 2000, I'm at 9157. I'm going down to 8712 in the year 2010. So that right there is telling me what I need to do with this rate. That's going to be a drop. So as I set up my formula here, A of t, again, it's based off of this information. Okay, so we're starting with that formula here. Now, in our case, we have to look at the information that we're starting with when t is equal to 0, which is the year 2000. So as I start inputting my information for problem 1, the first thing that I know is that my initial value would be the 9,157. Then from here, I have to determine, okay, so what's happening with this rate? Well, if my population is going from 9157 down to 8712, that has to be a decay here. So I'm going to be subtracting that 0.4%, which would be 0.004 as a decimal. And then that's to represent any year t. So all we need to do then is just clean this up, okay? So what happens is I get the 9157, 1 minus 0.004 is the 0.996 that you should have had as one of your possible answers, okay? So you'll notice that the other possible answers that you had for that one, I took the 8712 and put it in there. I made things as an increase. I did a whole bunch of different things, so you had to choose the right one. Okay, so the other ones were potential mistakes that students could make. Now, in part 2 or second question here, is this a decay or is it a growth? Well, in this case, if I calculated here correctly or I started processing the problem, I would find that this is a decay. And I wouldn't want to talk about it just as a number here. I would talk about it in terms of context. And it's a decay because our population is decreasing from 1 year or from 2000 down to 2004, down to 2010. Okay? So part number 2 would be decay because the population is dropping. Okay, so that was one of your issues there, is what was happening. Okay, so it wasn't related to just the number itself. We want to make sure we keep it to context. Then in problem 3 then, all we're doing is now we're trying to figure out, well, what would be the population in the year 2014? Okay, so in problem number 3, in the year 2014, we would have to recognize that t is equal to 14. And so all we have to do then is just plug it in. 9157 times 0.996 to the 14th power. So that would be the amount of people in the year 2014. And that turns out to be then 8,657, give or take a little bit of a decimal here, which we're not going to have a half a person, so we would just take it to the nearest decimal. Okay, and so that would have been your answer in problem number 3. Now, problem number 4 was definitely the problem that extends you here. Okay, so in problem number 4, they're saying that we're trying to figure out what year it's happening that we get 2,000 people. Okay, so essentially they're taking this formula here and they're saying, okay, now we're going to let the total number of people be 2,000. So this was a problem where all you could do was start checking answers. Okay, so trying different things to calculate for t. Now later on, we're going to have a way we can actually solve that using some other methods. So this again was the extension here, which in this particular case, what you would end up doing is just checking numbers and checking numbers. And many of you would have found you had to go really high. It ends up being, and again, it's not perfect here, but it ends up being 379. So well past our deaths. And when we calculate that, that turns out to be roughly or approximately 2,004 people. So somewhere within that year, that's when it's going to happen. So the year, which is what you were asked for here, would then be, since year 0 is the year 2000, the year would be 2,379. Okay? And that would be the final answer then for problem number 4. Okay, so that's your quiz. So at this point in time, everybody, if you did start working on the 7.2 material, I can cover some things there. It is not a requirement yet because we will be looking at that quiz. Oh, wait a second. Take the quiz today, we go over it tomorrow. Was that correct? Did I restate wrong? Did I state wrong, Zaria? Because we want to go over the quiz tomorrow, yes? Give me a response, Zaria. Was I off on my, did I do something off on that? Okay, that's what I thought I said. Is that we would take it tomorrow. I can meet real quick if people want to for the quiz on that. Okay, I'm going to step off of here real quick, everybody. I'm going to go back and look at my agenda. Give me a second. I'm not going away. I'm just going to go look at what I had written on the agenda earlier this week. So you're going to be looking at me as I'm scrolling here. Okay, so I'm looking at it right now, and what I wrote on, let's see, when did I write that? On Saturday last week. This is what I wrote in the agenda, is that I wrote that today we would do a live feed at 11 a.m. to go over the quiz, and then tonight you would watch and do the notes on assignment 7.2. Then tomorrow we'll do a live feed for questions on 7.2, and then the lesson quiz will follow after that. So we're going to stay to that schedule as we work through it. Okay? But since some of you may have looked at some of the questions, I will cover a couple of the questions. So let's take a look at it. I got to pull something up here real quick. So, nope, don't worry about it. So Zaria, not a big deal, but I can take a look at a couple of questions if people did. So if you've got a question you want me to look at, go ahead and post it. I'm going to pull up the worksheet, so I'm going to be here. But again, I'm going to be looking at something else. So you just got to watch it, me sit here and click. My wife came in the room. She's now sitting here looking at me, trying to make me laugh. She's doing a good job. She's getting me to break. She's too embarrassed to come and say hi. I'm almost there. All right, so I'm back. All right, so I'm going to adjust a couple of things here. Are you sure you want to wait till tomorrow? We don't have to. And here's what we can do. This is what my wife is doing to me right now. She decided to come in here and just stare. So now she won't even look at the camera. Hey, they're saying hi to you. Rose just said hello. Zaria said hello. Everybody say hi to my wife. Tell her I can do number 1. Yes, I will do number 1.
There you go. Do number 1.
No, wait a second. There's more that want to say hello to you. So let's at least have a little fun with this. Take the pillow away. See, now they're all saying hi. Look at this.
Okay.
They're all coming in.
Yeah, you should do that.
No. Take the pillow down.
Sir, you're wasting valuable class time.
Did you hear that? She says I'm wasting valuable class time. Can you believe that? Here it is, that we're trying to have a little bit of fun, and that's what she does to me. Okay, so we're going to take a look at number 1. So number 1 on the assignment, and again, this is, if you haven't taken a look at the questions yet on the quiz or taken a look at the lesson, is perfectly fine. She's making faces at me. Okay, wait a second there. I'm out of focus. See this pen? It's going bad. Guess who got it? All right. Problem number 1. Oh, she's now throwing things. She gets detention. Okay, so problem number 1 that you're looking at in the new assignment, you're dealing with 4 to the power of 2x plus 3 is equal to 1. Now, here's what we have to keep in mind, is that in these particular problems, your goal is going to be to generate a same base. So the issue here is that I can't really do anything with 4. I could change it to base 2 here, but it's the 1 over here that tells me, well, I can't really do that. So what I need to do, though, is I need to think about 1, and how can I write that as base 4? So in other words, that's the question I need to ask. How can I write 1 using base 4? Okay, so that's the big question here. Well, we have to keep in mind one thing when it comes to exponents. If I have an exponent, I can take any base I want. Let's say 3. Okay, I'm using a different base than what I am here for purpose here. I could have a base of 3, I could have a base of 5, I could have a base of y. Doesn't matter what it is, but if I raise it to a 0 power, as we have seen earlier this year, if I have any type of base raised to a 0 power, the result is 1. So the base can be anything I want, even a variable here, but if it's raised to a 0 power, the result is 1. So in our particular problem, what I would need to consider here then is rewriting the 1 as 4 to the 0 power. So then when I look at the remainder of the problem, now my bases are the same. So if these are to be equal to each other and the bases are the same, the exponents would have to be equal to each other. So I could argue that 2x plus 3 is equal to 0, and now I can solve from there. So I would get 2x is equal to negative 3 by subtraction, and x would be equal to negative 3 over 2 by the final division. And there is how I would handle that. Okay, so the big key is getting that same base. That's what this entire assignment is going to be about. Okay? All right. Do we have other ones that we want to take a look at? Okay, do we have any others we want to take a look at? Okay, number 9. Number 9. Can you go grab my phone? Quickly, quickly. I don't know if we're going to get to it. Okay, so number 9. Okay, I missed it, didn't I? Yeah, okay, so, okay. I know it's out of focus here. We'll get it in just a second. Okay, so we have 6 to the 3m. We're multiplying it with 6 to the negative m. And that is equal to 6 to the negative 2m. Okay, so now in this particular case, since I'm already in same bases here, all we're going to do is we're going to take a look at this and rewrite this side. So notice that since it's same basis here, when I multiply same bases, I get to add exponents. So I can argue here and say 3m plus a negative m, or just 3m minus m. That has to equal 6 to the negative 2m. Okay? So when I do that, I've got to get down to a single base on each side that matches. So then from there, I can now set my exponents equal to each other. So I'm going to do a little math here. So this would say that 2m is equal to negative 2m. All right? My wife now has the dog here, and she's now using the dog to make me laugh. So she's trying to throw me off here. All right. So from here then, what I'm going to have to do is I'm going to bring these together on the same side. So since I've got them equal to each other, I've got to treat these now like they're like terms. So I think I'm going to add 2m to both sides. So I'm going to generate a 0 on the right, add the 2m here, so that's going to give me 4m, division by 4, and we'll get m equals to 0. Okay, so this one, it's just a matter of bringing everything to one side and solve it, since you had like terms when you finish out. Now, we could have made an argument here as well from this line that the only way that 2 times a number is going to equal negative 2 times a number is when the number is 0. Okay, it wouldn't work with anything else, because 0 is the only way that those two can be equal to each other, because one is negative and one is positive. Okay, all right, let's take a look at 14. And again, be advised that tomorrow during our live feed that some people might ask those same questions if they chose not to stick around, and that's perfectly fine as well. Okay, so looking at number 14. Okay, you can't divide by m because m is what you're solving for. Okay, so our goal is to figure out the value of m. If I'm dividing by m, I end up limiting it. Okay, so that's why I need to bring it across as a like term. Okay, the other way to look at that one, okay, so we had 6 to the 3m times 6 to the negative m is equal to 6 to the what did we have, 2m? Negative 2m? The other thing you could have done is you could have looked at it that was a division. Get it all to one side. I'm not going to suggest you do that. Okay? But we have to keep in mind is since we're solving for m, we don't want to divide by that m. We want that to remain. Okay? All right, looking at problem number 14. All right, so in this one, we have 6 to the negative 2x multiplied with 6 to the negative x is equal to 1 over 216. Okay? So in this particular case, as I look at it, since the 6 is over here, I can't change those to any other base. That's going to tell me I need to deal with the 216. Okay? So in the 216, what I'm going to want to do with that is I'm going to want to see if I can rewrite 216 as base 6. My wife is being mean to me. So looking at 216, I think I'm going to divide that by 6, and let's see what we get. So 6 times 3, that's 18. We get a 36, 6 times 6. So notice that that's going to be essentially 6 times 36, or 6 times 6 times 6. So we could say that that would be 6 to the third power. Now, because this 6 to the third power is in the denominator, what I need to do with this one is I need to take this entire piece and think about how it transfers to become something in the numerator. In this particular case, if it's a positive exponent in the denominator, we can write it in the numerator, except it would have to be a negative exponent. Okay? Then on the other side, I can go ahead and combine those as a single base, add the exponents. So that would give us 6 to the negative 3x, negative 2x minus x. Now your bases match, so now we can set the exponents equal to each other. Division by negative 3, and we get x is equal to 1. Okay? All right. Does that make sense on problem number 14? This is who she keeps doing things to me. So there's our little runt of a dog. Okay. Do we have any others we want to take a look at? All right. 21. Okay, looking at problem 21. Oh yeah, this one looks like it's a little involved, isn't it? All right, so in 21, we have 1/6. Must be something with sixes on this today. To the 3x plus 2 is then equal to the other side. We have 216, or times, missing one thing, times 216 to the 3x is then equal to 1 over 216. Okay, so something that obviously is going to speed us up here a little bit is we already know that 216 is equal to 6 to the 3rd power. So that's gonna make this a little bit quicker, because what do you think I'm going to do with the 216s? I'm going to change those to 6 to the 3rd power then. Now, what I have to keep in mind on this first part is kind of what we did on the last problem as well, is that this is a 6 to the 1st power in the denominator. So when I rewrite this chunk, it would be 6 to the negative 1st power, okay, bringing that up to the numerator. So again, I'm taking a look at this chunk inside the parentheses and bringing it up as a negative exponent. Then on the outside, it stays as a 3x plus 2. Now I'm going to be a little careful here. I'm going to put that in parentheses because that's how it needs to interact with the negative 1 here. The 216, I'm going to rewrite that as 6 to the 3rd power, as we saw in the last problem, but that's still raised to the power of 3x. And then on the other side, in this case, very similar to that last problem, is that I can look at that 1 over 216, I can look at that as 1 over 6 to the 3rd power, and then move it to the numerator as a negative exponent. So that would allow me to say that that would be 6 to the negative 3rd power. Okay? Then from there, now we're ready to start cleaning up a little bit. So I've got to be a little careful. I want to get this all done. So I can say, let's say in this first one, it'd be 6 to the negative 1 times 3x plus 2 times 6 to the 9x. I can go ahead and multiply those. The negative 1 here, I got to make sure I distribute. And then is equal to 6 to the negative 3rd power. So now from here, I just have to keep in mind what happens. In these, I add them. So I could argue that this would be 6 to the negative 1 times the 3x plus 2. But I'm adding the 9x. And that then is equal to 6 to the negative 3rd power. Okay? Now I can go ahead and look at my exponents, Okay, so I have to keep in mind that this whole chunk right here is what's representing my exponent, and I'll be able to clean it up in the next step. So I'd get to say negative 1 times 3x plus 2 as a quantity, plus another 9x is now equal to negative 3. Bases are the same, so exponents have to be equal. Now solve by distribution, negative 3x minus 2 plus 9x is equal to negative 3. Now let's bring some things together. Negative 3x plus 9x is 6x. And then solve from there. Add 2. Divide by 6. And there is our result. Okay? So that is definitely an involved problem. Okay? Definitely an involved problem. Okay. So let's call it good from there. Gives you some time to take a look at some of the other problems that you may have had as you were working. You can then hopefully utilize this to help you through some of the other problems and some of the little nuances that we've got to be careful of. Go back and rework some problems, see how they go. And then we'll see you all here tomorrow for the live feed for other questions. And then we'll get into the lesson quiz after that. So at this point in time, everybody, have a great afternoon. If you can, get outside. It's a little nice today. Might as well enjoy it because we go on 2 weeks of complete lockdown starting at midnight tomorrow. So get out there and enjoy it the little bit that you can. So from there, quiz will be posted here in just a moment, and you'll be good to go. Have a great day, everybody. We'll see you tomorrow. Take care. Stay healthy.